Hello, welcome to the Center of Math's Advanced Knowledge Problem of the Week. In this week's problem, we're given the force function f of xy equals negative yx, and C is the circle of radius 2 centered at the origin, oriented clockwise, and we're being asked to find the work done by F along C. So the first thing that we should do is write down our equation for finding work with a line integral. So let's go ahead and do that. So we know that work is going to be given by the line integral along the curve C, where f of r of t dotted with r prime of t dt. And r of t is the parameterization of the curve. So the first thing we have to do is parameterize our curve, and then we're going to step-by-step go through and find each of these components before putting them into the integral. So we've got our curve is a circle of radius 2. So our parameterization is going to be pretty obvious. So the parameterization of our curve is going to be 2 cosine of t as the x component, and the y component is going to be 2 sine of t. So r cosine of t equals x, r sine of t equals y. So let's go ahead and derive this. So r prime of t is going to be negative 2 sine t, 2 cosine t. And so now we have r prime of t, so let's just go ahead and find f of r of t. So f of r of t is going to be negative 2 sine t, 2 cosine t, so it's the same as r prime of t. So let's go ahead and find the dot product of these. So when we got these together, we get 4 sine squared of t plus 4 cosine squared of t. And if you remember your trigonometry rules and identities, then you know that this is equal to 4. So we're going to be taking the integral of 4 along the curve C. So we know that that C is a circle, so it's obvious that you can pick any limits that describe a complete circle. I think the most obvious are 0 and 2 pi. But since it's oriented clockwise, if we pick those two limits, then it's going to have to go from 2 pi to 0 to show that it's a clockwise oriented curve. So when we plug that in, we get that the work done by F along the curve C is going to be negative pi joules. So that concludes this week's Advanced Knowledge Problem. Make sure you check us out on Twitter and Facebook, and take a look at our blog at centerofmath.org. Thanks.